in this video, let us evaluate by changing into polar coordinates. So this is the given question. So they have given x varies from minus a to a outside. So it means x varies along the axis from left side, always x is left to right, left side minus a to right side plus a. So we have drawn the diagram, and this is minus a and this is plus a. So left side my diagram starts at minus a and right side it ends with plus a. This is what I have said. Now for this, y is equal to 0 to y is equal to root of a square minus x square is along the curve. So down is the curve y is equal to 0 and the upper part is the curve. Y is equal to 0 means this line, that is the x-axis line equation is y is equal to 0. The entire line is y is equal to 0. Even here also it is y is equal to 0. Now what is the upper part? Y is equal to a square minus. So if I square it, y square is equal to a square minus x square. Therefore, x square plus y square is equal to a square. This is nothing but the equation of a circle. So this is the circle I am talking about. So now we have drawn a circle. Mark the point minus a to a. Now from where to where? So x is from minus a to a. Left side minus a it starts. Right side it ends with a. Again, what is the lower region of the curve? It starts from down, y is equal to 0. It starts from y is equal to 0. So this is the starting point. But though the outside is, this is also y is equal to 0, I am stopping here. Let me use green color, where I am starting from here and ending here. Though entire equation is y is equal to 0, my restriction is from minus a to a only I have to draw. So this is this line, and if you see here, this is the region that we have to find. So y is equal to 0 is the lower value and x square plus y square is equal to a square is the upper value. So this green shaded region is the region that I have to find. Now I have to change it to polar coordinates. Always for changing to polar coordinates, use this set of formula. X is r cos theta, y is r sin theta. Therefore, x square plus y square is r square cos square theta plus r square sin square theta. If you take r square theta is 1. So, you are going to use the formula x r cos theta, y r sin theta, and x square plus y square is equal to r square, and dx dy is equal to r dr d theta. How we got r dr d theta? All those things will be given as a separate proof. So for the time being, for polar coordinates, use these formulas by default. So now we are going to change the question. That is, now I am going to write for theta and r the limits. Theta varies from, now if you see the circle, that is the shaded region that I have given, not the bottom of the circle, only the top of the circle is shaded. So what is the angle from here to here? I will use a different color. From here to here, the angle is pi. So theta varies from 0 to pi. And any point, if you take this x square plus y square, in the given question they have given a square. Correct? So according to this substitution, I will say a square is r square. Therefore r is nothing but a. Correct? So from the center the radius is a. So r varies from 0 to a, and already what is there inside in the question? Root of x square plus y square, that is root of r square, and then dx dy I will write it as r dr d theta. So that r square will come out, so it will become theta varies from 0 to pi, r varies from 0 to a, this r into this r will become r square dr d theta. So r square, if you integrate, you will get r cube by 3, 0 to a d theta, integral 0 to pi. Okay. So now if you apply the upper limit, in the place of r you will substitute a, and then the minus lower limit in the place of r you will substitute 0. So only upper limit exists, because the lower limit will become 0. We get I is equal to theta varies from 0 to pi, a cube by 3 d theta. Now we are going to integrate only with respect to theta. A cube by 3 is a constant. D theta, if you integrate, you will get theta, and this is the limit 0 to pi. When you apply the upper limit pi, so you will get pi a cube by 3 as the answer. So this is how you have to change to polar coordinates. Keep this in mind. X is r cos theta, y is r sin theta, x square plus y square is r, and dx dy is r dr d theta. So let us see one more example. If you see this problem, they have given x varies from, so now they have given dx dy, right? This is x varies from, this is y varies from. So now they have given 0 to infinity. So when they give 0 to infinity, in this case, what will happen? This is x-axis. This also goes to 0 to infinity. Y also goes to 0 to infinity. So in this case, this will be the distance for any point p of x comma y. This will give you r and this will give you theta. Correct? So now same substitution, x square plus y square is equal to r square. So what is the maximum limit? X varies from 0 to infinity, y varies from 0 to infinity, means 0 to pi by 2 is the maximum angle. So I will write it as theta as 0 to pi by 2. And r varies from 0 to infinity, because I don't know where this x stops, y stops. R will not stop here. R will be keep on growing because x is also growing, y is also growing. So r varies from 0 to infinity. And then e power minus x square plus y square is nothing but already same substitution. X is equal to r cos theta, y is equal to, so we are using x square plus y square is r square. So e power minus r square, and then dx dy is r dr d theta. Same substitution we are using it. And now we are going to integrate with respect to r, and if you see here, we have e power minus r square. Since it's tough for us to integrate, so what we are doing, we are substituting, let r square is equal to some t. So what happens? 2r dr is dt dt by 2. Because if it is e power minus t, then it is easy for us. So we can't do it because it is e power minus r square, power is 2. So I am just substituting this as t. And what will happen to the limit when t is equal to 0? When r is equal to 0, which implies t is equal to 0. When r is equal to infinity, t also becomes infinity. So your I value varies from, theta varies from 0 to pi by 2. Now instead of r, we have the limit for t. T varies from 0 to infinity, e power minus t into dt by 2. Second substitution we are doing. Here in the place of minus r square, I am substituting minus t, and in the place of r dr, I am substituting dt by 2, and outside d theta is there. So now e power minus t is an easy thing to integrate. So theta varies from 0 to pi by 2, I am keeping as it is, and e power minus t, if I integrate, e power minus t by minus 1. So with this I can write it as minus e power minus infinity. Then t varies from 0 to infinity d theta. What is the value of e power minus infinity? It is 0, and e power 0 value is 1. So we are going to use this. So when you apply the upper limit, I will become theta is equal to 0 to pi by 2 minus 0. Again minus lower limit. This minus and this minus will become plus e power 0. So this you can write it as one more step. Okay, d theta. So I am just using these two values. So I varies from theta 0 to pi by 2. First term becomes 0, second term becomes 1, d theta. So d theta, if you integrate, you will get theta within the limit 0 to pi by 2. And then we missed this by 2 here, dt by 2. So 1 by 2 will be there outside everywhere till the end. So here also 1 by 2, here also on 1 by 2. So 1 by 2 into pi by 2. So which is nothing but pi by 4. So this is how we change the integral from Cartesian to polar, and we are evaluating. Thank you.